Next talk is given by Oliver Montenbroek on multi-GNSS activities.
Welcome at this time of the day, wherever it is on your location. My name is Oliver Montenbroek, and I'm happy to introduce you to the work of the Multi-GNSS working group within the IGS. I'm chairing this since almost a decade now, and the agenda, the charter of the Multi-GNSS working group has been slightly revised over time, but it basically comprises to conduct the Multi-GNSS pilot project, which is the successor of what was formerly called MGEX, the Multi-GNSS experiment. We want to promote a comprehensive integration of multi-GNSS tracking and analysis into all IGS components and activities. As part of that, we consult and liaise with other IGS working groups so that multi-GNSS is properly considered in all standards and data formats. We promote the generation of comprehensive multi-GNSS orbit and clock products. In fact, the multi-GNSS working group comprises a couple of ACs that generates those products on a routine basis since many, many years. And we want to support the buildup of multi-GNSS orbit and clock product combination process, which will then allow a final integration of multi-GNSS into the routine operational IGS work. And we want to increase the public awareness for multi-GNSS work and facilitate access to relevant information through the contribution on the IGS website. The progress over the last 2 years has been a partial implementation of the latest IGS workshop recommendation. We met actually almost 3 years ago in Wuhan, where it was recommended to move to long product file names. That has all been implemented. However, we have not made progress so far to store the multi-GNSS products using the new file names in the standard IGS directory tree. So you still have to look in the data centers at slightly different places for the multi-GNSS products than for the standard products. There had been a recommendation to generate and host multi-GNSS ultra-rapid products. Currently, there is one analysis center, Wuhan University, that generates such products within the MGEX pilot project. And we have some work on prototype implementations for orbit and clock combination processes under the lead of GFZ and Geoscience Australia, two independent activities which we will in the future have to combine into one final utility for such combinations. And there was also a recommendation to promote the generation of multi-GNSS receiver antenna calibrations. That's a closed item thanks to many efforts of Geo++. We now have a very decent set of multi-GNSS, multi-frequency antenna calibrations for receiver antennas. Key accomplishments over the last 1 or at most 2 years. Personally, I had a very big involvement in the RHINEX 4 establishment, the new navigation format, which Nacho has already introduced. So we now, basically as of today, we have a new format that allows us to store all the different types of navigation messages generated or broadcast currently by the diverse constellations on the new modernized signals that they offer. We have added a multi-GNSS performance monitoring on the multi-GNSS or MGEX website that comprises information on the orbit quality based on satellite laser ranging, information on the clock behavior of those satellites, to name just a few items. And we have continued to maintain the GNSS satellite metadata file, which is also distributed currently via the MGEX website, and to post information on the new constellations on the website there. The GNSS satellite metadata file has, I think, now been is a widely accepted standard interface now for providing all those data of satellites that are of generic property that describe generic properties, be it the mass evolution, the transmit power, the association between blocks, vehicle types, and space vehicle numbers and PRN numbers, to name just a few items. And that will hopefully, once it is fully integrated by analysis centers, will hopefully allow us, for example, also to simplify the Antex format in a future release. Just as a continued activity, there are currently 6 analysis centers providing multi-GNSS products for up to 5 constellations, and those are routinely provided and continuously refined. And Tom Herring has already mentioned that the quality of those products is continuously increasing over time. I may admit that there is one constellation, namely IRNSS, which we cannot currently support. There is no analysis center addressing that. And that is mainly because there are no receivers offering IRNS tracking on 2 frequency right now. That might change as IRNSS is introducing L1 signals in their future spacecraft, but for the moment, work on IRNSS is a bit dormant in the IGS. Concerning the status, as of now, we have roughly 370 multi-GNSS stations. It probably depends a little bit on how you count it. Dave Maggart counted a few stations less, but it's more than 350, which I think is a substantial fraction of the overall IGS network, and allows everything that you want to do in the term of multi-GNSS, from orbit and clock product generation to ionospheric data analysis, and whatever you like can be done now. There is a sufficient network for almost every constellation. We had 3 satellites or 4 satellites that were added to the various constellations. We have a new GPS 3A satellite launched this year. We have quite recently the replenishment satellite for the very first QZSS satellite. And just 2 days ago, or 1.5 days ago, we had the launch of 2 more Galileo satellites. On the constellation side, there have also been important additions. Beidou has added a PPP service limited to the Chinese mainland, and Galileo is expected to come up with a high accuracy service next year that will allow, hopefully, PPP directly by signals transmitted from the satellites. Aside from the, say, product generation that I have mentioned before, generation of orbit and clock products, we had done a couple of studies inside the working group or by different institutions. We have continued to do a flex power monitoring and DCB generation, considering flex power on GPS. We have pilot software development for multi-GNSS orbit product combination with variance covariance estimation done under the lead of GFZ. We have monitored Earth orientation parameters, or rotation parameters to be more precise, transmitted by the modernized navigation messages of GPS, QZSS, IRNSS, and Beidou. And we are currently working on a product assessment for Beidou 3 satellites together with the various MJEX ACs. Future work will be still the pending work to move the IGS, the MJEX products to the standard IGS product directory, to continue the work on multi-GNSS product combination, to bring together the results of GFZ and Geoscience Australia, and also to see how clock combination can be added to the orbit combination that is currently in progress. We should also look into the antenna and multi-signal handling, just to name a few items here. The Antex format extension for code and gain patterns. Arturo already mentioned that briefly in his talk about Antex. The antenna working group activities, that a new Antex 2.0 format should be established, and we want to say support that work from the MGX working group. We probably have to work on concepts for handling, on the one side, frequency-specific antenna data, on the other side, ionosphere-free estimates of antenna phase centers. That is a bit of a conceptual conflict for a couple of GNSS satellites. We do have manufacturer calibrations on individual frequencies, whereas all estimates provided in the IGS are based on ionosphere-free dual frequency combinations, and that is a bit difficult to apply to triple frequency processing, for example. So that's where the MGX working group has again to work together with the antenna working group and maybe the PPP working group and others. And that was also briefly mentioned by Stefan Scher 10 minutes ago, the pending issue of generating clock products for GPS L5 users. A wider community, particularly the space user community, is very much interested in that. And in a couple of years from now, we will hopefully have a full GPS L5 capable constellation. So the IGS must then be ready to also support that frequency in a consistent manner. And that concludes my talk, and I'm open for any questions that you may have.
Thanks so much, Oliver. I don't see any question from the chat. My only comment is that, of course, we are on the way to a real multi-GNSS service. But nevertheless, we still need a working group on multi-GNSS. And of course, when I see your presentation, this is something like obvious. So we need this working group. We need you as a chair. So thanks again for all your activity. And well, let's continue on this way. Thanks again, Oliver.